Welcome, Regents physics students. Today's topic is multi-layer refraction. This also happens to be the sixth and final topic within the optics unit. So after today, we're done with material in the optics unit. So, as we already learned, light bends when it goes from one material to another. And we can figure out the degree of bending from Snell's law on the reference table in the wave section. As you could see, the formula n1 sine theta 1 equals n2 sine theta 2, you can solve for theta 2 inside of another material, and by this equation we could figure out light bends towards or away from the normal depending on how the speed changes when you go from one substance to another. So today we're just going to expand that a little bit and analyze what happens when we don't have just one boundary but multiple boundaries. Light goes from one substance to another to another. The first thing that you need to be able to do, and maybe the only thing regarding multi-layer refractions, is to know the general pattern of the angles in the various material. I put the indices here for air, zircon, lucite, and air. 1, 1.92, 1.5, and 1.0. Again, those come from page 2 of the reference table. Underneath the electromagnetic spectrum, we have this table here, and we could say, see air's 1.0, zircon 1.92, lucite 1.5, air 1.0. So we get them off this table right here. Okay? And as you should remember from the Snell's law topic, the bigger the index, the smaller the angle. And so what you will know is when you see this light coming in like this, the light doesn't go straight in through the zircon. It bends towards the normal because we're going to a higher index. Okay? And then when we get to the lucite, we're going now from a high to a low. So this light should bend away from the normal. However, the index is still larger than air's, so the angle of 73 degrees in the air cannot be exceeded here because the index is still bigger, so we cannot go beyond 73. The angle has to be somewhere between zircon's angle and air's angle, so it bends just a little bit away from the normal. Then, when the air goes in this boundary from the lucite to the air, once again, we go to a lower index, just like we went low here, lower again. So again, we bend away from the normal. And what you should know is that going to the same index we started with, the angle here will be the same that we started with. Okay? So you might just have to sketch the overall pattern of the bending of light as it goes from one material to another. So if you went something like this, towards the normal and then towards the normal again, that would be incorrect. Towards, slightly away, away back to the original based on the relative indices. Again, that might be all you're asked about multi-layer refraction on the Regents, if you're even asked that at all. Might not even come up at all. But you might also have to calculate all these angles. And this is how we would do it. Theta 1, 73 degrees. What is theta 2 right here? We would just start with Snell's law. n1 sine theta 1 equals n2 sine theta 2. In material 1, we have an index of 1, that's the air, and an angle here of 73 degrees. In material 2, we have an index of 1.92, and then the angle is what we're looking for. We divide both sides by 1.92 and then do the inverse sine. To stay efficient today with the notes, I didn't show all the algebra, I just show the answer, 29.9 degrees. So go ahead and jot that down. So now the angle right here is 29.9. From simple geometry, we can see that when it comes and hits this surface right here, this angle is the same as this one. So this theta 2, which is the refracted angle, the angle of transmittance in the zircon, becomes the angle of incidence at this boundary. And so we can use at this boundary, we can use Snell's law again, okay? But we use N2 and N3 and sine theta 2, sine theta 3 because we're going between substances 2 and 3. So this time the index in substance 2 is 1.92. The angle right here is 29, like the angle we found out here. And then the index in lucite here is 1.5. What is the angle? That's the unknown. We divide both sides by 1.5, evaluate all this on the calculator, then do the inverse sine, and we get theta 3, 39.6 degrees. So that's the angle right here. Now, that light ray, 39.6 between the normal and the ray, that's the angle of refraction or angle of transmittance. That becomes the angle of incidence when it comes into this surface right here. 39.6, 39.6. And we have another refraction right here. So we repeat our calculation with Snell's law again. But this time, we're between substance 3 and substance 4. So we put in index of lucite, substance 3, and the angle in substance 3. We put the index in substance 4, and the angle in substance 4 is unknown. So we divide both sides by 1, we evaluate all this and do the inverse sine, and we get 73 degrees. Again, as I mentioned before, it's the same as this 73 here because we're returning to the same index. So that's all the analysis is for multi-layer refraction. It just means you're going to be doing Snell's law at every single boundary and getting all the angles. Okay? So not too much more difficult than what you already know how to do. Last point I want to make though, broad view. If you look at what we did, we used Snell's law between boundaries 1 and 2, and 1 sine theta 1 equals N2 sine theta 2. We got an answer. Then the next thing we did is we used Snell's law between substance 2 and substance 3. N2 sine theta 2 equals N3 sine theta 3. We solved for theta 3. We got an answer. And then at the final boundary, we did Snell's law between substance 3 and substance 4. Essentially what we have is A equals B equals C equals D. And so from math, you know that if A equals B equals C, you could say A equals C. Or B equals D. You could use any of these four terms and equate them to each other because they're all equal. Why do I point that out? If a problem asks for theta 3, but not theta 2, so it gives you theta 1 and it's asking for theta 3, you can skip layer 2 and directly calculate angle 3. So only calculate what you need to. You can set 1 equal to 3, 1 equal to 4, or any pairs and get the number of what they're asking you to calculate. Okay, so that's multi-layer refraction. Again, what you might have to do is just figure out the pattern of the way the rays bend and sketch quickly, and boom, you're done, just from the concepts. The bigger the index, the smaller the angle, and so you kind of estimate the path of the light ray. Or you might have to use Snell's law multiple times to get all the angles in between. Multi-layer refraction. Okay, so that's it for optics. I'll see you in the next physics video for the next topic.